Okay, so this kind of problem is actually a related rates problem, and you're trying to basically relate two pieces of information together with respect to some other variable. For problems like this, it's really important to take into account what you're given and how to kind of incorporate all the variables together. So we're going to start with what exactly are they asking you to do the related rate for. So oil spilled from a tanker spreads in a circle whose circumference increases at a rate of 40 feet per second. How fast is the area of the spill increasing when the circumference is 100 pi feet? So I'm asked for how fast the area increases with respect to time, because the unit here was increasing with respect to time. So our circumference with respect to time, so that's a derivative, is increasing at 40 feet per second. It's really, really important that you pay attention to the units. They usually help you out in the problem. For instance, this represents either a length or a circumference or a perimeter. And here, this is a time unit, which lets me know I'm going to take the derivative with respect to time. The second piece of information they gave me is that the circumference at a specific point in time is 100 pi feet. Now I need a formula for the area of a circle. So our area formula we're going to use is pi r squared. The first thing you need to do is take the derivative of both sides with respect to time. This is implicit differentiation, meaning you're going to have derivatives left over as long as your derivative your variable you are taking the derivative of isn't time. So there's no time in this equation. A is area, r is radius, so we're going to need a variable for both. So here we have dA dt equals 2 pi r dr dt. So if I'm looking at it like this, my problem is I know what the circumference is, and that actually is 2 pi r. I don't know dr dt, so I'm actually going to have to go back and find dr dt. So let's set up a formula for circumference now. So circumference is 2 pi r, and we're going to take its derivative with respect to time. So we have the derivative of the circumference with respect to time, which we have something to plug in there, equals 2 pi, and the derivative of r is just going to be dr dt. So solving this for dr dt, we have 40 equals 2 pi dr dt, and we divide both sides by 2 pi, and we get dr dt equals 20 over pi. So that's going to go here. So we have dA dt equals, and 2 pi r is our circumference, so we can just plug 100 pi here. dr dt is going to be 20 over pi, and this is over 1, so notice your pi's cancel, and you are left with 2,000. Now we need some units. Area is in feet squared in this case, and the time was in seconds. And that's it for this problem. So this kind of took two steps of two different related rates to get this problem finished.